Okay, in the previous video we have discussed what a line of symmetry, yeah, what an axis of symmetry is. Okay? And now there are few shapes, and I would like you to draw the axis or the line of symmetry on these shapes. I really hope that you remember what a line of symmetry does. What does a line of symmetry do? A line of symmetry divides a shape into two mirror images or into two symmetrical shapes. Okay, I hope you remember that. Okay. Now there are few shapes. These all are regular polygons. This is an equilateral triangle. This is a pentagon, and this is a hexagon. Now I want you to draw lines of symmetry on these shapes so that these shapes are divided into two mirror images or into two what we call that, into two symmetrical shapes, whatever. Okay, anyways, that. So first of all, let's start with this one. This is a hexagon, and I want you to divide it into two halves, into two symmetrical halves. Okay, so first of all, the first line that I can draw maybe is like this. Let's say this is the first line of symmetry. Let me just, okay, this is the first line of symmetry. This is the first thing that you are going to get. I'm going to give you a shape like this, and you are going to be asked to draw lines of symmetry of that shape. So this is the first line of symmetry. Okay. If you look at this here, look at this image. Okay. This is just what this is. Obviously I'm just using this shape to explain it to you in a better way. Okay. So this is same as this one, and I am saying that I've drawn a line of symmetry which is this. Okay. If this is the line of symmetry, then obviously this half, this one, is the mirror image of this. These two halves are symmetrical to each other and identical to each other. Okay. And this whole shape is symmetrical. If this really is the line of symmetry, then what should happen? This is what should happen. Okay. In the similar way, this will also happen if I draw a line of symmetry like this or like this. Okay. So these are very easy things. Okay. These are two lines of symmetry. First of all, one in this way, and maybe the other one in this way, like I shown you. Okay. So the first line of symmetry was like this, and the other line of symmetry was like this. Now, think, can a line of symmetry be drawn from this vertex to that in this way? Okay. If yes, then what should happen? This is what should happen. Okay, is that clear? And in a similar way, a line of symmetry can also be drawn from this point to this point. Is that correct? If that is correct, then this is what should be happening. Okay. So obviously you are not going to get these kind of things when we ask you to draw lines of symmetry. I'm just using it here right now just to make sure that you are getting to understand it properly and you get to see what is actually happening. Okay. So what was the first line of symmetry? First line of symmetry was from this side to the opposite side, from the midpoint of this side to the midpoint of the other side. So the other line of symmetry is going to be this. This has to be congruent, and then this is going to be one more line of symmetry. Now I've done the sides. I've taken this side and this side. This is the first line of symmetry. From this side to this side, and from the middle point of this side to this other side. This one. Okay. Now comes the vertices. I have taken this vertex, from this vertex to this. I have drawn one line of symmetry. Now this is the other vertex. From this vertex, the line of symmetry should go to that vertex. So the line can be divided like this as well, and then this as well. I have made a mess of it, but there are how many lines of symmetry? One. Then let's say this. Two. Then this is the third one. Three. Okay. These are drawn from the middle point of the sides to the middle point of the other side. Now let's talk about the vertex. This is the fourth one. Then, sorry, this is the fourth one. Okay. This is fifth, and this is, let's suppose, let's say 6. So how many lines of symmetry are there in a regular hexagon? In a regular hexagon there are 6 lines of symmetry. Okay. Next shape is a regular pentagon. How many lines of symmetry could be there? Obviously there are no opposite sides. In this shape we had opposite sides, but when we have 5 sides over here, so obviously no pair of sides are opposite sides to each other. So I can draw a line of symmetry from this vertex to the midpoint of the side opposite to this vertex, which is this. So the first line of symmetry is going to be like this. Okay, from one vertex to the midpoint of the opposite side. Then this is the other vertex. What is the opposite side to this? This one. Okay, so from this vertex to the midpoint of the opposite. Then from here to here, this is going to be something like this, and this one, and last of all, this. So how many lines of symmetry are there? 1, 2, 3, 4, and 5. Let me just show it to you very briefly. This is the pentagon that I have drawn over here. Okay, I can draw a line of symmetry from this to this point. This is going to be like this. Okay, in the same way, this to this side to this. Sorry, this vertex to this side, and this is also good. Okay, and we keep on. So there are 5 lines of symmetry. So you can conclude from these polygons that when I have a regular hexagon, how many lines of symmetry did I have? I had 6 lines of symmetry. When now I have a regular pentagon, so how many lines of symmetry do I have? 5. What is this? This is a regular octagon. So if I ask you how many lines of symmetry will be there in an octagon, in a regular octagon, so how many lines of symmetry will be there? There will be 8 lines of symmetry. Okay? And then in the end, a triangle. It's an equilateral triangle. Okay? It's not just any triangle. It's an equilateral triangle. In an equilateral triangle, there will be how many lines of symmetry? Yes. Hexagon, 6 equal sides, 6 axes of symmetry. Pentagon, 5 equal sides, 5 axes of symmetry. Octagon, 8 equal sides, so 8 lines of symmetry. So in an equilateral triangle, 3 equal sides. How many lines of symmetry should be there? I hope somebody guessed. 1, 2, and 3. Okay. So if you have a regular shape or a regular polygon, you will have same lines of symmetry as that of its sides. If I am talking about a decagon, there will be 10 lines of symmetry. Okay. So on, and that will keep on going. So if I am talking about a square is a regular polygon in which all 4 sides are equal. So in the case of a square, how many axes of symmetry should be there? There have to be 4 axes of symmetry. Okay. By the way, regular polygons are the shapes in which all the sides and all the interior angles are equal. It's not just that only sides are equal. Okay. All the sides of the shape, including the interior angles, all the angles must also be equal. Remember this property. Any closed shape with equal length of sides and equal angles are the regular polygons. Okay? This is what we have taught you already. So this property will help you understand if I have a regular polygon, then how many lines of symmetry should be there? The lines of symmetry will be same as that of the sides. Is that clear? This is the first thing. You are going to get few shapes and we are going to ask you to draw the lines of symmetry. If you have the book 2, this book 2 is the one in which we are going to discuss question from you. Book 2. 7th edition, this is chapter number 13 that you are supposed to do a few questions from. First of all, if you have the book right now and if you don't have the book, please make sure that you have it. Okay. On page number 360, work the example 1, practice now 1. Okay. These are few things that we are also going to discuss, and then on page number 361 there are few more examples, and then 13a, exercise 13a is on page number 364. The questions that you must do. Question number 1. Which of the following shapes have no line of symmetry at all? There are few shapes given in question number 1. There are few shapes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 12 shapes given in this question. And they're only asking you which shapes do not have the lines of symmetry. So you might just try drawing lines of symmetry over those lines and then think, are the halves symmetrical halves? If the halves are symmetrical, then you can say we have that many lines of symmetry, whatever. Okay. There's parallelogram, rectangle, a square, and then a decagon maybe, whatever. You can just have a look at the question. And question number 2, how many lines of symmetry are there in each of the following shapes? So there are first two questions in exercise 13a, page number 364, book 2 again. Now after this explanation that I have taught you here, how to draw lines of symmetry on these shapes, and if you have seen my previous video as well, so now you would have understood, okay, what is a line of symmetry, what is an axis of symmetry, what is a line of reflection, what is an axis of reflection, and what are symmetrical shapes and what is symmetry. A shape is symmetrical if it has axis of symmetries. Okay? So now try doing the first two questions of exercise 13a. Hopefully you will be able to perform those questions. These questions are for those students who have not done axis of symmetry earlier in the previous year. So kindly please make sure that if you have not done these questions earlier, make sure that you do it, because I am just doing these things for those who have not done this thing or those who have forgotten. Okay? So kindly make sure that you just go through this exercise and do the questions that I have mentioned here. In the next video, I will be discussing one more thing about axis of symmetry, and then we will move to rotational